Hello my dear students, hope all of you are doing well. Let us understand one example of shear force and bending moment. So, to determine shear force and bending moment for any particular beam, first of all we have to start with the support reactions, right? The same we have already seen in the previous lectures, how to determine support reactions. Now, for this simply supported beam AB, for this particular support, this support is hinge support. So how many reactions we have for hinge support? We have two reactions, horizontal and vertical, right? So horizontal reaction at A and vertical reaction at A, and this one is roller support. For roller support we have one reaction, right? Now to determine reactions we have to apply equilibrium condition. So our first equilibrium condition is algebraic sum of all forces in x direction is equal to 0. Right side is positive and left side is negative. Now for this particular beam we have only one horizontal reaction, that is reaction at A. So horizontal reaction at A is equal to 0 because we don't have any other horizontal reaction. Now the another one equilibrium condition is algebraic sum of all forces in y direction is equal to 0, and our assumed sign convention is upward positive, downwards negative. Okay, so let us carry out the summation of all forces in y direction. Ra is acting upward, so it is positive. 7 is acting downwards, so it is negative. Now this 10 is acting downwards, so it is also negative. Plus Rb is acting upward, so it is positive, is equal to 0. So Ra plus Rb is equal to 17. So summation of forces in y direction is equal to 17. Now our third equilibrium condition is algebraic sum of all moment about any point is equal to 0. Here our assumed sign convention is clockwise positive, anti-clockwise negative. So now let us take the moment of all forces about A point. Now the line of action of this force, that is Ra, and line of action of this force, that is Ha, it is passing through A point only. So we don't have any moment of this two force about A point because we don't have any distance. So Ra into 0 plus Ha into 0, right? Now moment of this force about A point, remember our reference point is A, so you have to take distance of that particular force from A point only. So 7 into 2, and what about the nature of moment? Nature of moment is clockwise, so it is positive. Now moment of this force 10 kilonewton, distance from A point, reference point is 2 plus 1, that is 3, and the nature of moment is clockwise. See, and arrow then A point clockwise, right? So 10 into 3 clockwise. Now for this particular force Rb into the distance from A point is 3 plus 1 plus 2, that is 6. And what about the nature of moment? Nature of moment is anti-clockwise, and that's why it is negative, right? So summation of all moment about A point is equal to 0. From this we determined reactions, that is Rb is equal to 7.34 and Ra is equal to 9.66 kilonewton, right? Now let us draw shear force and bending moment diagram. For the same, first of all we have to go for calculation of shear force, right? Now you have to take section at each and every point. So we will take section at A, C, D and B, okay, where the force is there. So starting with the A point, now this is our left part of the section and this one is the entire right part of section, okay. Now what about the shear at A? Shear force, that is a summation of vertical forces at either left or at the right of section. Right now for the entire beam we are considering left part only, okay. Again I am repeating, we are considering only left part. So we are going to do summation of vertical forces in left part only, right? So what about the shear at A? we have shear, that is 9.66 kilonewton, and again it is upwards, so it is positive, right? Now shear at C. Now divide the beam over here. This one is the left part, AC part, and CB is the right part of beam, right? Let us consider the left part. So in the left part, how many vertical forces we have? One is 9.66, another one is 7 itself, right? So 9.66, that is upward, minus 7, that is downward. So the shear at C, that is equal to 2.66 kilonewton. Now shear force at D. Again, divide the beam into left part and right part. Our left part is DA, our right part is DB. Considering the left part, how many vertical forces we have? One is 9.66, another one is 7, and another one is tan itself, right? So let us carry out summation. 9.66 upward positive, minus 7 downwards negative, minus 10 downwards negative. So finally we will have minus 7.34 kilonewton shear at D, right? Now shear force at B. Again, considering the entire left part, means entire beam AB, right? So here up till this we have already calculated, and our value is minus 7.34. Up till D point our value is minus 7.34, right? So up till D point we have minus 7.34 plus this reaction, that is RB, and again it is plus 7.34. So shear at B is equal to 0, right? Now for the drawing of shear force diagram, so where the point load is, we will have the vertical line. Where the uniformly distributed load, we will have inclined line. And where the UVL, that is uniformly varying load, we will have parabolic line. And if we don't have any load, we have to show the same with the horizontal line. Okay, now let us draw shear force diagram. Okay, these are our values: shear at A, shear at B, shear at D, and shear at B, right? Now let us draw the diagram. These are our points. Okay, here upward of this line, okay, above this line we have positive shear, below this line we have negative shear. Let us start with the A point. At A point we have positive 9.66 kilonewton, right? And the same we have to show it with vertical line, because at A point we have point load, right? So at point load you have to show shear by vertical line. So 0, and here the value is 9.66. Now see, in between AC part, do you have any load? If you don't have any load, you have to show the same with horizontal line, because the shear remains constant up to C point, right? So it is 9.66 kilonewton constant up to C point. Again, what about the same? Again we have 7 kilonewton over here, right? So shear at C again decreasing, and the value is 2.66. So from 9.66 our value is decreasing, and the value is 2.66 kilonewton. Again at the point load we will have vertical line, right? Now in between C to D part, do you have any load? We don't have any load, so we have constant shear of 2.66 up till point D, at the up till the just left of point D. Now at D we have also 10 kilonewton, so our value is decreasing to minus 7.34. So from 2.66 it is minus 7.34, right? So at negative value we have to show below this line, so it is minus 7.34. Now in between D to B, do you have any load? We don't have any load. Again we have a constant shear, and we have to show the same with horizontal line, right? And constant shear of minus 7.34. And at B we will have the value of shear is 0. Finally the value of shear is 0, right? So this is about the shear force diagram. Again see, here we have vertical force, so we will have this vertical line. Here we don't have any load, so it shows by horizontal line. Again vertical load, again vertical line, again we don't have any load, and again we don't have, again we have a constant shear. Okay, and the same over here, right? And this one is positive shear, this one is negative shear, and where the shear is 0? At point D. Now for the bending moment diagram, for the bending moment diagram, our sign convention is clockwise positive, anti-clockwise negative. Okay, now let us start with the A point. Now here this is the hinge support. At hinge support we don't have any bending moment, so because hinge support don't carry any moment, we have only two reactions for hinge support, that is horizontal and vertical. So at hinge support the value of bending moment is 0. Now at C point, right, at C point take a section and consider the left part of section means AC point. Consider the left part of section means AC, right? Starting with this, now remember one thing, where you are taking section, that is your reference section, right? From this reference section either you can consider left part or you can consider right part. If I consider left part, what about the value of moment? That is 9.66 into 2, distance from reference section, and the moment is clockwise, and that's why it is positive, 19.32 kilonewton into meter, right? Now at D point, 1 minute, at D point, considering the left part of section, what about the value of moment? The moment of this force about D point and the moment of this force about D point, right? Moment of this force about D point is 9.66 into 2 plus 1, that is 3. Now our reference point is D. Okay, so you have to take moment of all forces about D point, but remember we are considering left part only, that is AD part. Okay, so we have to take moment of all forces about D point in left part only, right? So 9.66 into 3, and the moment is clockwise. Okay, minus 7 into 1 because this moment is anti-clockwise, right? So bending moment at D is 21.98 kilonewton into meter, right? Again bending moment at B is 0. Why it is 0? Because this support is roller support and we don't have any moment at roller support, because roller support can take only one reaction and that is vertical, right? So roller support don't carry any moment, so bending moment at B is 0. This moment is also clockwise and this moment is also clockwise. Now how to draw bending moment diagram? If you don't have any load, it shows by inclined line. If you have UDL, then it shows by second degree parabolic curve, and if you have uniformly varying load, it shows by cubic curve of third degree, right? The moment that is shown by vertical line, right? Let us draw the bending moment diagram. Now these are the value. Bending moment at A and B is 0. Only we have to show our positive moments of 19.32 and 21.98 at C point and D point. Starting with A point, at A we don't have any moment, moment is 0. From AC part we don't have any moment, so let us show the same with the inclined line. If you don't have any moment, show it by inclined line. At C point we have 19.32. And again the value is positive. Okay, if you have positive value, you have to draw the diagram above this line AB, and you have negative value, then draw this diagram below this line AB, right? Now in between C to D you don't have any moment. At D again you have 21.98, right? And again B you don't have any moment, then again show it by inclined line, join it by inclined line, and the value is 0. Now see, your entire diagram is positive. Yes or no? Diagram is positive. And why it is positive? We have already seen the same in last lecture. If you have this type of loading, with the simply supported conditions. What about the deflected shape? Now, do you remember which type of deflected shape this is? This is sagging shape. Okay, if you have a sagging shape, definitely you will have positive bending moment diagram, and the same result is there for this simply supported beam with the downward loading conditions. You have positive bending moment diagram, right? So this is about how to draw shear force and bending moment diagram for simply supported beam with simple loading conditions, right? Now, if you have any query, any questions, please mail me at structurelengineeringconcept@gmail.com, and please don't forget to like, share and subscribe.